today's problem from numerical analysis and the solution of a given system of linear equation using Gauss-Seidel method or Gauss-Seidel iteration method. A system is given here and this problem taken from UPSC main optional math second paper from 2021. Okay. Here the system is given by this. We first test that the system is diagonally dominated or not. What is diagonally dominated? If in a system mod AII greater equal to summation j equal to 1 to n and j not equal to I and mod of Aij, yes, then this system is diagonally dominated. That is, if the diagonal element or magnitude of the diagonal element is greater than the sum of all the other elements of this row. Here it is clear that this is 10, right, for the first equation, and the sum is, the right side is mod of -2 plus mod of -1 plus mod of -1. So this sum is 2 plus 1 plus 1, this is 4, and this is 10, so this greater than 4. So the first equation is diagonally dominated. For the second, similarly we get 10 greater than mod of -2 plus 1 plus 1, and similarly for the third and similarly for the fourth. So the system or given system is strictly diagonally dominated. Okay, here we write given system is strictly diagonally dominated. Okay, now since the system is strictly diagonally dominated, now we write the iteration scheme of Gauss-Seidel method or Gauss-Seidel iteration method. Now write the iteration scheme. Iteration scheme of the method, of this method. We get, or iteration scheme of this method is, from the first equation we find the value of x1 and x1, let this is k plus 1 at iteration, x1 k plus 1, this is given by 1 by 10 into 3 minus, we take all the other term in the right side, so this is 2 x2, this is kth iteration plus, sorry, this is plus, this is x3, this is also kth iteration plus this is x4, this is also kth iteration. Okay, this is the iteration scheme for the first equation. From the second equation we get x2 k plus 1, this is equal to also 1 by 10 into, here right side is 15 minus, sorry, this is plus also 2x1, here we put k plus 1, because in Gauss-Seidel iteration method we put the value of x1, that is we put the current value of x1, here we get in the first equation the k plus 1 iteration of x1, so we put here x1 k plus 1. Okay, and all the other element, that is plus x3 k plus x4 k, because x3 and x4 in the kth iteration now. Now from the third equation we get x3 k plus 1, this is 1 by 10 into 27 minus, sorry, this is also plus x1 k plus 1, already we find the k plus 1 iteration of x1 plus x2 k plus 1. Okay, that is x2 k plus 1 means we already get the k plus 1 iteration of x2, and now plus 2 into 2 into x4 k, because we not find the value of x4 in k plus 1 iteration now. Now in the last we get or we write x4 k plus 1. This is also 1 by 10 into this is minus 9 plus x1 k plus 1, because x1 k plus 1 already get, and plus x2 k plus 1, because x2 k plus 1 is also find here, and this is 2 into x3 k plus 1. Okay, and this is the iteration scheme of Gauss-Seidel iteration method. Now here no initial approximation or initial value of x1, x2, x3, x4 are given. In this case we take the initial value of x1, x2, x3, x4 are 0. Okay, let initial value of x1 0, this is equal to x2 0, this is equal to x3 0, this is equal to x4 0, this is equal to 0 we get here, because here no given initial value of the variable. Okay, and if the initial value are given, then we put the initial value, and if not given, then we take this are all equal to 0. Now putting the initial value of 4 variable, we get the first approximation of x1, that is x1 1, because if we put k equal to 0 here, then we get x1 1, and the right side is given by 1 by 10 into 3 plus 2 x1 0, sorry x2 0 plus x3 0 plus x4 0. Okay, and by putting 0 0 0 we get this is 0.3. And now the first approximation of x2, this is x2 1, which is given by 1 by 10 into, we put the initial approximation of x2, x3, x4 here, x3, x4 here, but we put the first approximation of x1, because we find here x1 1. Okay, so we get that is 15 plus 2 into 0.3 plus 0 plus 0. Okay, here also we put k equal to 0. Then this value x1 1 we put here, and x3 0, x4 0 we put here. Okay, so we get the value, this is 15.6 by 10, this is 1.56. For the first approximation of x3, we get x3 1, this is given by 1 by 10 into, this is 27 plus x1 1, x1 1 means 0.3 plus, this is x2 1, x2 1 means 1.56 plus 2 into x4 1, sorry x4 0, so this is 2 into 0. Now calculating this result we get, we already calculate here, and this is given by 2.886, and this is the first approximation of x3, right? Now x4 1, we put here all the first approximation of x1, x2 and x3. Okay, and this gives 1 by 10 into minus 9 plus the first approximation of x1, this is given by 0.3, and this is given by 1.56, and the last is given by 2 into 2.886, and calculating we get the result as minus 0.1368. Okay, these 4 are the first approximate value of x1, x2, x3, x4. Okay, now we find the second approximation of x1, x2, x3, x4. How to find x1 2, and this is given by 1 by 10 into 3 plus, we put here the value of, sorry 2 into x2 1 plus x3 1 plus x4 1. Okay, and now 1 by 10 into 3 plus 2 into, what is x21? The value of x21 is already given here. This is 1.56. We put 1.56 plus x31. x31 means this is 2.886. So we get 2.886 plus x41. This is given by minus 0.1368, and calculating we get the result as the second approximation of x1 is given by we write here, this is 0.88692. Okay, and similarly we find the second approximation of x2. This is x22, which is given by, we put here a equal to 1. So this is 1 by 10 into, this is given by 15 plus 2 into x12. We put here x12 because we already get x12, second approximation of x1. And this is x31 and this is x41. Okay, now put 1 by 10 into 15 plus 2 into, this is x12, so we put 0.88692 plus x31. x31 means this 2.886 plus x41. This means minus 0.1368. 1368, and calculating this result we get the second approximation of x2, which is given by 1.952304. Okay, and by similar manner we write directly here x32, which is given by we directly write, this is 3.1613064, and we get x42, second approximation of x4, which is given by, this is 0.0161836. Okay, and continuing this process we have to find for this problem 4 iterations. Okay, this is very lengthy problem but very easy problem. We can calculate by putting the previous iteration in the next iteration scheme, right? And we easily find the fourth iteration of, or fourth approximation of the variable x1, x2, x3 and x4, right? This is the method and this is the solution of this problem. Thank you for watching.